So in this video, you can go over on how you can be able to actually on how you can be able to tag up the problems to do with hypothesis testing. And before this actual lesson, just have to make sure that you have gone through the lesson that we discussed about, formulating the null hypothesis as well as the alternative hypothesis, and also how to find the critical values and are giving the level of confidence on the normal or curve, and also how to actually determine the alternative hypothesis as well as the null hypothesis, as we are to make use of those in this video. So just have to make sure that you are really in line with those actually videos, and also you have to remember about the steps required to go over on the hypothesis testing. So those videos will be very important. That is talking about the video we discussed about the steps required to actually have the hypothesis testing, and also the video we discussed about how to find the critical values, and also the video we discussed about formulating the null hypothesis as well as the alternative hypothesis given the conjectures. So those videos will be very important, so take note of that. And also you should not have to forget to have the normal table before you, because it will be very important as well as far as this lesson is concerned. And also about the steps required to have the hypothesis testing, in case you missed that one. You should also have to go through that one. So now, let's say we have this case. So let's say this is the typical question. A researcher wishes to see if the mean number of days that a basic low price small automobile sits on the dealer's lot is 29. A sample of 30, or actually the sample of 30 automobile dealers has a mean of 30.1 days. Now for the basic low price small automobiles. Now at alpha is equal to 0.5, test the claim that the mean is greater than 29 days. So actually the standard deviation of the population is 3.8 days. So how should we be able to have that out? So now, the first thing we should have to understand about what is the alternative hypothesis and what is null hypothesis. But the first thing we actually identify what is the null hypothesis. So in this case, the null hypothesis, it is about the information which is already being known by the people. Or in other words, that is the information or the object in which everyone knows about. In other words, that is the mean in which everyone knows about. And the one who is to test that particular idea is to be a testing with respect to. That is the actual null hypothesis. So in this case, the general fact that it is actually known about, it is said to be the null hypothesis. It is given as the H naught mu is equal to 29. So that is the null hypothesis. It should be given as the mu is equal to 29. So what is the alternative hypothesis? Now we should have to go to this statement. It states that at alpha is equal to 0.05, test the claim that the mean time is greater than 29 days. Now, upon having a 30 automobile dealers, should be a 30 automobile dealers, the mean that they observed is said to be 30.1, which is greater than 29. So we should have to test the claim that the mean which is 30.1 can be said to be it is greater than 29 days. What does it mean is that in that case it means the alternative hypothesis, which is given as HA, is given as the mu is greater than 29 days. That is the principle behind that. So since it is since it is greater than, it means this is the one-tailed test, and it is actually a light-tailed. So bear that in mind. So which means this is the null hypothesis and this is the alternative hypothesis, as you can see, because we are being literally told that the mean is said to be 29, that is, and the alternative hypothesis has to be in the sense that we should have to claim that the mean time is greater than 29 days, which is greater than, so that is one-tailed test, and which is light-tailed. So now you know what it means there. So what is the next step? Actually, what is the next step upon having the hypothesis, that is the null hypothesis as well as the alternative hypothesis? So now the next step is to have the critical value. So how do you find the critical values? I understand you know what is the critical value and how you get it up to. So we are told that the alpha is given as 0.05, and since the alternative hypothesis is said to be greater than, it means this is the light-tailed. So that will be given as light-tailed. So what is the critical value with respect to that one? So since it is light-tailed, it means we'll have the complement of the alpha, that will be given as 1 minus 0.05. That will be given as 0.95. So which means we are to look for the critical value corresponding to this one, is actually 0.95. What is that one? And of course the value which is much closer to this one is that of 0.9495, and at least this is the value which is much closer to that one. Then what is the value up here and what is the value in this case? So we'll have it as, and there should be 0.4 up here. We'll have 0.4. I understand you know how to have the critical value according to the video that we discussed it already. And for this case, we'll have it as 1.6. So what is the combination of these two values? Then we'll have the critical value. So now which means the critical value will be given as this. So which means the critical value, which is given as CV, will be given as 1.64. So this is the critical value. Then we should have to indicate it on the normal curve. I understand you know what is the normal curve is all about. That is the very important idea to understand about the normal curve concept. So let's see, this is the normal curve. So since the value is positive, it means it is in this direction, in this side. So we'll have it as 1.64, and since it is light-tailed, it means we'll have to shade this region. So now in this case, this is said to be a rejected region. So this is said to be a rejected region, or the critical region. Now should be rejected region, and this is accepted region. So take note of that. And now this is the rejected region because that's the region in which the alternative hypothesis is favoring to. And this is the accepted region because this is the region where the null hypothesis is favoring to. And from there we should have to calculate the test value. How should we be able to have the test value in this case? So now the formula to have the test value is given as, that should be the symbol for the test value is the same. Actually, the way we calculate the test value, the symbol itself is the same way we calculate the z-score, which is given as z is equal, that should be x bar minus mu divided by the standard deviation divided by the score of n, where n is the sample size. So should be a population size or the sample size, whichever in that case. So in this case we'll have it as, what is the actually x bar? That is the sample mean, and which is given as 30.1 minus, what is the mu? Now that is the 29. So have it as 29 divided by, what is the standard deviation? We have it as 3.8, and divided by the square of, what is the sample size? We have it as 30. So take note of that. As now, the calculations now will give us now the test value, which is the value of z, will now be given as the z is equal to 1.59. That is the value of z. Now we should have to compare the z value with respect to the testing value, that actually the critical value that we have. So now, which actually part between the accepted region and the rejected region is the testing value is located? So you can see that we have the center given as L, and this is 1.64, and up to this point, up to this actual side. So which means the testing value, which is 1.59, it is located within the accepted region. So if that's the case, then it means we are accepting the null hypothesis, and we are rejecting the alternative hypothesis. So since the testing value is located within the accepted region, so that's how important it is to have the normal curve, as we already discussed this one about when we were calculating about the critical values. So now, since the testing value is found within the accepted region, therefore we are accepting the null hypothesis. That is to say, really the average has to be the average has to be given as 29, and we are crushing actually the alternative hypothesis. So take note of that. And had it been that the testing value was found within the rejected region, it means we would have rejected the null hypothesis and are accepting the alternative hypothesis. So bear that in mind. And now let's go for this question. The Medical Rehabilitation Education Foundation reports that the average cost of rehabilitation for the stroke victims is 24,672. That is the well-known fact, and well actually standardized fact that this is the average in that case. Now, to see if the average cost of the rehabilitation is different at a particular hospital, a researcher select now a researcher wishes to see if really the average is given as this one. So which means the actual null hypothesis will be given as the mu is equal to that one. So now to see if the average cost of the rehabilitation is different at a particular hospital, a researcher selects a random sample of 35 stroke victims, that is the sample size, that is the value of n, and at the hospital, and finds that the average cost of their rehabilitation is 26,000, and are given as this. So that is the sample, actually a mean, which is given as the x bar. Now the standard deviation of the progression is given as this. So I understand what that actually that is. I understand you know what is that one. And now at alpha is equal to 0.01 should be that. Can it be concluded that the average cost of the stroke rehabilitation at a particular hospital is different from this one? Now the way it is said to be different from this one, it means it is tutorial test, because despite that the average that has been obtained is given as this one, but there is an expectation that the average is not equal to this one, and the average has to be different from this one, and that can be greater than as it has been observed here, or can be less than that. That's why it is said to be different from this one. So this is a two-tailed test. And much as you can remember about the way we discussed about, and that should be the way we can be able to discuss, and the way we discussed about how we can be able to interpret the phrases behind the null hypothesis as well as the alternative hypothesis. And there is also the lesson about that one. Try to check it out in case you missed that one, but you come across that one. We discussed about some of the phrases that you should have to understand about whenever you are to go about the null hypothesis as well as the alternative hypothesis. And that is a very important lesson as well for you to have to understand before this one. So take note of that. So how should you be able to go about that one? So now the null hypothesis will be given as the mu is equal to 24,672. That is the null hypothesis. And what is the alternative hypothesis? We'll have it as the mu is not equal to 24,672. So which means this is the two-tailed test. Then next we should have to evaluate what is the critical value. To understand, you know how to have the critical value. So now we have the alpha being given as 0.01, so that one. And that should be now a two-tailed test. What is the critical value if that's the case? So we understand that in this case we'll have to divide the alpha by 2. We'll have 0.01 divided by 2. What will be that one? I'll have it as being given as should be 0.005. No, should be this. Now we'll have it as 0.005. That is upon having the division. The next we should have to have the critical value with respect to this value on the normal table. Now what will be the critical value? It should be critical values because that is the two-tailed test, which means we'll have the two critical values that are the same in magnitude, but the one is it will be positive and the other one will be negative. So critical value with respect to should be 0.005. What would be that one? So what is the critical value associated with 0.005? So 0.005. So up here we have 0.08. In this case we have 2.5. So if we combine, we'll have it as 2.58. We just have to literally combine. And even if we could have, let's say negative 2.5, and we could have just have to combine, nothing to do with algebra, just have to combine. We could have had it as negative 2.58. While if you think of having the concept of algebra there, it won't be that. So the critical value will be given as 2.58. So now since it is two-tailed, it means you know the principle behind. We'll have it as plus or minus 2.58. So take note of that. Then now how to present that on the normal curve. That is the very important key to understand about. So this is the typical normal curve, where we'll have this side as the negative 2.58 and this side we'll have it as the positive 2.58. So these are the rejected regions, of which at first we called them as the critical regions at the time we were discussing about how to find the critical value and shade the critical region as well as and I should be indicating the critical region as well as the non-critical region. Now we are calling those regions as rejected region. This is also rejected region, and this is now accepted region. So take note of that. Then we should have the test value. What is the test value? And what is the formula for us to have the test value? So the formula says that the test value is given as the z is equal to, now should be x bar minus mu divided by the standard deviation divided by the square root of n. Now in this case, with the calculator, I'll have it as 3.04. That is the testing value. Then from there, we'll have to compare. Where is the value located within the curve? So now, as you can see, the value is located within the rejected region because this is 2.58 and this is 3.04, which is also positive. It means the value is located within this side. So therefore, we are rejecting the null hypothesis, and should be really there is actually, and it is really true that the average cost of the stroke rehabilitation at a particular hospital is different from this one, because the actually a testing value is located, actually it is found within the rejected region. So take note of that. So that's how you should have to understand about the principles behind how you can be able to go over on the hypothesis testing. So let's finalize with this question. Now, a researcher claims that the average cost of men's athletic shoes is less than $80. He selects a random sample of 36 pairs of shoes from a catalog and finds the following costs. Now, these are the costs you should have to understand. Now, is there enough evidence to support the researcher's claim at alpha is equal to 0.10, and assuming that the standard deviation is given as this one? So, what is the null hypothesis? So now, the null hypothesis is given as the mu is equal to 80. So, that's what, now the mu is equal to 80 because now a researcher is trying to claim that the mean is less than this one, of which at first, what is the information which is already being known is that the mean is equal to this one. Now the researcher is trying to claim that the mean is less than this one. So which means the alternative, actually the null hypothesis is said to be the mu is equal to $80. And what is the alternative hypothesis? Mu is less than 80. That's a way to go. Then which means this is actually a single torus that is left out. So you'll be able to have everything out, and actually at your own time try to go through that one, of which we are not being given the sample mean. With this information we'll be able to have the mean, and likely enough we have the standard deviation. And also, had it been that the standard deviation is not being given, we can be able to have the standard deviation either using the Lenge approximation formula or using the formula for the standard deviation. That is said to be computing formula for this. Actually it should be computation formula for the standard deviation. You can also be able to have that one out. Or else, if we're being given the variance instead of the standard deviation, you can be able to have the standard deviation using the relationship between the standard deviation as well as the variance. I understand you know what is to be done there. So try to have this one at your own time, that is, and try to go through a lot of problems to do with hypothesis testing, and I should be able to get used in those problems. So thank you.